Java debugging. What are JVM stack traces? Imagine trying to find your way through a maze with a trail of breadcrumbs. That's what a Java stack trace does for you when your program hits a snag. It shows the path your code took up to the point of failure. But to really understand what's happening, you need to know what the JVM stack frames are and how they fit into this picture. Every time a Java method is called, the Java virtual machine creates a small data structure called a stack frame. Think of it as a tiny container that holds all the information needed for that specific method to run. When the method finishes, that container is discarded. This push and pop process keeps the program organized and helps track what's happening at each step. A JVM stack frame has three main parts. First, there's the local variable array. This is like a small storage box where all the method's parameters and local variables are kept. For example, if your method takes an integer and a string, those are stored here. Primitive types like int or float take up one slot, but larger types like long or double need two slots. Smaller types like byte or char are converted to int before storing. Next is the operand stack. This is where the JVM temporarily holds data during calculations. When your code performs an addition or comparison, values are pushed onto this stack. The JVM instructions then pop values off, perform operations, and push results back. It's a quick way to handle intermediate steps without cluttering the local variables. Finally, each stack frame contains some metadata, like a reference to the constant pool, which holds constants used by the method, and the return address. The return address tells the JVM where to go after the method finishes. This information helps the JVM jump back to the right place in the code once a method call is complete. Each thread in a Java program has its own JVM stack, which means each thread has its own set of stack frames. When a method is called, a new frame is pushed onto the thread stack. When the method ends, the frame is popped off and control returns to the previous method. This orderly process makes it easy for the JVM to keep track of nested method calls and returns. Understanding JVM stack frames is key when you look at a stack trace. Each line in the trace corresponds to a specific stack frame, showing which method was running and where in the code the error occurred. If you see a line pointing to a method, you can look inside its stack frame to see what local variables were in use or what calculations were happening at that moment. Knowing about stack frames also helps you diagnose errors like stack overflow. This happens when too many frames are pushed onto the stack, often because of infinite recursion or very deep method calls. By understanding how frames are created and destroyed, you can identify where your code might be going wrong. So, in simple terms, JVM stack frames are the building blocks of method execution. They hold all the data needed for each method call and help the JVM keep everything organized. When you understand how these frames work, reading stack traces becomes much easier, and fixing bugs gets a lot simpler.